Assalamualaikum and good morning to our lecturer, Encik Khirwizam. We are Group 6 from DKM5A. Today we are presenting about Case Study Part 2. Our group members is Aidil Ashraf, Muhammad Arif Hakimi, Mas Farish Quazuddin, Muhammad Ikmal Adli and me, Muhammad Afiq. So, the first question will be start by Muhammad Ikmal Adli.
Question A. This is the PV diagram and TS diagram. Okay. Process 1 to 2. Isentropic compression. In this process, the piston moves from BDC to TDC and compression of air takes place isentropically. It means that during compression, the entropy remains constant and there is no flow of heat out of the cylinder walls happen. Here the air is compressed, so the pressure increases from P1 to P2. Volume decreases from V1 to V2. Temperature increases from T1 to T2, and entropy remains constant. Next, process 2 to 3. Constant volume heat addition. In this process, the hot body is kept in contact with the cylinder and heat addition to the air takes place at constant pressure. During this process, the piston rests for a moment at TDC. The pressure remains constant. Volume increases from V2 to V3. Temperature increases from T2 to T3. Entropy increases from S2 to S3. After that, process 3 to 4. Isentropic expansion. In this process, after heat addition, the expansion of air takes place isentropically and work is obtained from the system. The piston moves downward during this process and reaches to BDC. The pressure falls from P3 to P4. Volume increases from V3 to V4. The temperature falls from T3 to T4 and entropy remains constant. Finally, process 4 to 1. Constant volume heat rejection. In this process, the piston rests at BDC for a moment and the cold body is brought in contact with the cylinder and the heat rejection takes place at constant volume. The pressure decreases P4 to P1. Temperature decreases from T4 to T1. Entropy decreases from S4 to S1 and volume remains constant.
Question B. Assemble with construct a block diagram that shows how the diesel engine starting system works in diesel power plant. So this is a diesel engine and in the circle is the starter. At first, start signal sent to starting motor air, electric or hydraulic motor and will engage engine flywheel. Next, starting motor will crank or spin the engine at a high enough RPM. Next, engine compression increase to ignite the fuel and engine starts running. Next, the engine accelerates to idle speed. And lastly, when starter motor is overdriven by the running motor, it will disengage the flywheel.
As we can see in this sketch, on the left side is use compressor or flow controller to lower pressure, large receiver for better compressor control, use efficient dryers and drains, properly maintains equipment, lower pressure level, recover compressor seat, optimize compressor control blade, access your system to create baseline and purchase compressors based on life cycle costs. On the right side is first fix air leaks, properly sized piping drops, use compressed air appropriately, properly size hose and fittings, educate air users about codes.
Okay, my name is Mas Farish Kuzudewi Maswaman Hussain. My number metric 01 DKM1F 1026. I answer question D. Okay, the answer of the category of float pump is rotary. Okay, this sketch is showing the liquid flow direction in suction, discharge and blades. As you can see, the liquid will enter to the inlet space and the white arrow is the flow path and will out at the outlet space. The working principle we describe. As the lobes come out of mesh, they create a spinning volume on the inlet side of the pump. Liquid flows into the cavity and trapped by the lobe as they rotate. Liquid travels around the interior of the casing in the pocket between the lobes and the casing. It does not pass between the lobes. Finally, the machine of the lobe forces liquid through the outlet port under pressure.
Question E. Vane pump is rotary pump. Illustrate the vane pump by showing the liquid flow direction in inlet or outlet, rotor and vanes. First of all, what is vane pump? Vane pump is a self-priming positive displacement pump providing constant flow at varying pressures. Vane pumps are commonly used as high-pressure hydraulic pumps and in automobile, including supercharging, power steering, air conditioning, and automatic transmission pump. The rotor is sealed into the cam by two side plates. Vanes or blades fit within the slot of the impeller as the rotor rotates and fluids enter the pump. Centrifugal force, hydraulic pressure, push rods push the vanes to the walls of the housing. The tight seal among the vanes, rotor, cam and set plate is the key to the good suction. The housing and cam force fluid into the pumping chamber through holes in the cam. Fluids enter the pockets created by the vanes, rotor, cam and side plates. As the rotor continues around, the vanes sweep the fluid to the opposite side of the crescent where it is squeezed through the discharge hole of the cam as the vane approaches the point of the crescent. Fluid then exits the discharge port.